friends, welcome back to my channel, Supriya channel. In this vlog I will be going to tell about the experiments done in the 4th semester. Usually I have done already 6th semester, I have shared that one. Now I am going to teach how the CRO and power supply and the signal generator what it will be going to operate. Now let us see first the CRO operations. In CRO operation, that this is the 30 megahertz frequency CRO and 20 megahertz frequency CRO also is there. Here I am using 20 megahertz. The maximum range is 20 megahertz. Only you can vary it. Here you can see these two knobs are there. This is channel 1 and channel 2 knobs. These two knobs are used to calculate the amplitude of the signal. And this knob is used for time per division. We will call it for this one time per division. This knob will be going to use to calculate the frequency. And these knobs are used for triggering pulses, means triggering to stop the waveform. Sometimes the waveforms will not be simultaneously synchronized. For that purpose we will be going to use these two knobs to stop the waveform. And these here all the variable positions. Please keep these two knobs in the locked position, or else whatever the magnitude of the amplitude of the voltage or signal you are varying, it may differ from your input or output. And this is the sweep variable knob where the frequency will be going to, it has to be, you can see here arrow mark is there for calibration, it has to be locked. Until unless if this varies, the frequency of the signal will also vary. Now I will say how to check the CRO probe. Both the channels I have already, in this knobs channels I have connected already the CRO probes. This one we called as a crocodile probes. This one will be the negative and this one will be the positive. To check the waveform we will tell stuff. How to check the CRO probe I am showing here. I am using only channel 1 CRO probe. I have connected already. You can see that square waveform is coming here. Here it is written 2 volts peak to peak, it will be there. As it is taking 1 unit into 2. You can see it is into 2 volts. So 1 into 2 volts, so peak to peak. And whether this probe is working or not, we will check it. To check the probe whether working or not, the positive terminal should connect it, and the ground terminal you have to ground it. You have to press it on the positive terminal, then it has to be ground. The reference line should come. That time the probe is working. Same way we will go for another also, and we will check all the CRO probes. Now I will show how I will be telling about the signal generator, what we are using here. In the signal generator there is a coarse and fine knob. It is these two knobs are used to vary the frequency, and this one knob is used DC offset voltage. It has to be always off. If it is on, then your output will not come, so better you keep it this in off position. And here the selector knobs are there for voltage. Here the 0.2 volts, if I select the 0.2 volts, the 0.2 volts will be the maximum, and millivolts will be the 20 millivolts, 10 millivolts. So if I select for 2 volts, the 2 volts will be the maximum and 0.2 volts will be the minimum. Same as 20 volts, 2 volts will be the minimum and 20 volts will be the maximum. To vary the amplitude ups and down, to set the voltage, we will be going to use this one. You can see here, if you press this read VP, the amplitude voltage means here not peak to peak, the single peak voltage it will be going to display, and it is varying. You can see that. So this knob is used to amplitude variation, and this knob is used to frequency variation. And so much confusion will be there to whether this digit, whether it is coming, it has to multiply to with this one. No, it is not multiplication. If you press 1K, then 1K will be the maximum, 100 Hertz will be the minimum. 100 Hertz, 200, 300, 400, like that up to 900, 1K. And when you go for 10K, if you press 10K, then 1K will be the minimum and 10K will be the maximum. And here you can see the different types of functional waveforms, means different types of waveforms: sinusoidal signal, triangular and square waveform. Now let us see whether to generate a square waveform, and I will show it. Now I have generating a sinusoidal signal at 1 kilohertz frequency and 10 volts peak to peak. Here 5 volts is single peak, 10 volts peak to peak should be there. So now you can see on the CRO, the signal is coming but it is jumbled. It is not synchronized properly. For this connection, you know positive of the signal CRO probe to signal generator positive, and negative to negative you have to connect. And you can see here it is waveform is not synchronized and it is not able to stop, and still if you varying the frequency time per division knob also. For that purpose, how we have to stop this waveform? To stopping the waveform, to trigger the waveform, we will be going to use these two knobs. From the beginning only I said that how it will be going to use it. If you want horizontally it has to stop, then go for TV horizontal. And which channel I am going to use? I am using channel 1, so go for channel 1. The output of the waveform or the input of the waveform will stop. So please see that it has to be horizontally. If it has to be done, then go for horizontal and go for channel 1. If you are using channel 1, go for channel 1. If you are using both the channels, then go for channel 2. See, you can see the waveform still it is moving because I have triggered only channel 2, but I have not connected here any channel 2. So whatever the channel is connected, please see that one and select that knob. Now you can see, and how much I have done, 10 volts peak to peak. Here you can see it is more than 10 volts. So use amplitude knob, decrease the amplitude knob to for 2 divisions such that the amplitude should come to 10 volts peak to peak. You can see the number of divisions on y-axis into time per division will give the voltage. Number of divisions on x-axis will into time per division will give frequency, but frequency formula F is equal to 1 over T. Total time you first calculate and calculate the frequency. Now it is 1 kilohertz frequency.